Hello everyone, and welcome to another episode of solving advent of code challenges in Rust and trying to learn Rust in between. I am Luciano.
Eugene.
Roberto.
So thank you everyone for following along. We are gonna try to continue from where we left off in the last episode. So we were working on exercise number 13, and we managed to complete the first part. And we were working towards the second part, and we had basically kind of a brute force solution, which was very slow. So it did work for the small input, but it didn't work for the actual input. By the way, if you never did Advent of Code is basically a coding challenge that is published every year in the before the Christmas period. We are working towards the last year's one, and basically there are 24 challenges, and you can find them offline. I think it's adventofcode.com. We publish all our code on a repository, which you can find here. And we also have a YouTube channel where we publish all the recordings, and you will find the link for that in the description of this Twitch channel. So let me share very, very quickly the code from last time, just to show you what we did and what was the problem. And then I'm going to give the drive to Roberto to continue with part 2. So basically, the problem for number 13, it's something like this, where essentially you have a list of numbers and x, where basically every number represents a bus, and you have to find certain combination of buses, basically. So in part 1, this one represents a timestamp, and every number represents not just the bus ID, but represents how many minutes it will take for the bus to be again at the first stop where you can take the bus. So imagine that these buses are going around specific routes. Every bus has a different route. But for instance, in this case, every 13 minutes, this specific bus, number 13, will be back at the starting point. And the first part of the problem, if I remember correctly, was about if this is our time when we arrive at the stop, what is going to be the earliest bus you can take? Is that correct?
Yeah. But okay. It was how many minutes do you have to wait for a bus to be there?
Yeah, so what is the closest bus that you can get arriving at the stop at that time? Yeah. And the solution was very straightforward. By the way, in that part of the exercise, all the X's, you can just ignore them. So the solution was fairly straightforward. What we needed to do is just pass the input, and then it was basically like searching for the closest value there, right? And the closest value...
Like a min function?
Yeah, it's a min on top of a function. The function is the one line 18 and 19.
Exactly.
So basically, it's the difference of the remainder of the timestamp by the bus number. Mm-hmm. Nothing complicated. Then you have to find the minimum number that come out from that, and keep track of that minimum and the bus that generated that minimum. And then you have the solution wants the ID multiplied the weight. Just a number to check.
Exactly, because basically the first timestamp is 0, so you can assume all the buses are starting at 0, and then you know that you can get basically you can check if at a given timestamp if the bus is there or not, or when it's going to be closer again, right? Because you know, for instance, bus 1 is going to be every 13 minutes, and depending on the number of the bus, you know that
bus 13 would be there every 30 minutes. Bus 1, if there was a bus 1, was there every minute.
Exactly. So that was fairly straightforward to do. The interesting thing that we learned, and by the way, thanks to Tommaso, who is watching us today here, hello. We learned that initially we were doing here a filter and then a map, because with filter we were removing all the X's in that input. And then with map, we were parsing the specific numbers into actual numbers. And then Tommaso suggested us to use filter map, which essentially is a way to combine the two operations into one step. It would be interesting to measure the performance difference, if there is an improvement or not, but that was an interesting learning. The other one was this parse OK, because parse is basically trying to read a string and convert it to something else. In this case, it's trying to parse a string as a number. And of course, this operation can fail. So parse is going to return a result, and that result is going to be an OK with a value if the parsing was correct, otherwise will be an error. While filter map is waiting for, is expecting as a response an option. So you need to give it some value or none, basically. If you give it none, it means skip this value from the iteration. If you give it some value, it's going to keep that value. And that value will be the map of some other value. So basically, with this .ok, you can also convert a result type into an optional type. So this was also another interesting learning. So we could write this entire filter and mapping in one liner by combining these two learnings. So that was cool. Now I think we can move on to part 2. And I'm gonna share Roberto's screen because, or do you want, Roberto, maybe I explain the difference of the problem here and then you try to explain the algorithm?
Go on explaining the problem, then I will explain how we improve this algorithm, because basically we are improving this solution that is slow.
Exactly. So the exercise 2, if we look again at the input, basically we can ignore the first line. So the first line doesn't mean anything anymore. And the second line has almost the same meaning. So it means that still every number is a bus, and that bus will be again at the starting point after a number of minutes that is the same as the number of the bus. But now what we want to do is we want to find a magic moment in time where all the buses will be arriving 1 minute after each other. So it's we want to find a little scale of buses in the future. Let's see if in the README we have an example where we can visualize that. Yeah, for instance, here, this was an example where you have this scale, but there is an exception because now the x's, they mean something. That basically means there is going to be a bus at any moment in time, basically. So you can, in a way, ignore all the x's, but they will move the scale forward. For instance, let's show the input here. This was the example. So the example here was 7, 13, x, 59, x, 31, 19. So that basically means 7, 13. Then you can imagine there is an x here in between. Here there are other two x's. No, so basically what happens is that the scale here...
There are two x's between the 13 and 59.
Sorry, there are... You're right, thank you.
And
two x's here and one here.
Yeah, the other way around. Cool.
So basically that means that from this one to this one, there needs to be exactly 1 minute. Then two x's, they kind of allow you to skip 2 minutes. So that's why here we have 2 minutes before another bus. Then there is 59, which 59, should it be?
There is 59 an X. Is the one you are on. 59.
Yes, and now there is an X here, so that's why there is another minute of gap. Yeah. And then this one to this one, there is only 1 minute from one to another. So basically, we need to figure out, we need to do a simulation, moving time forward until we find this magic moment in time where we know from that minute, every bus will arrive in the right order 1 minute after another.
I get that, but I don't fully get how the x's... I don't know if people in the chat actually got it, but I didn't get how the x's impact this.
Basically, the x's are moving the offset of the bus that is following. Mm-hmm. So you need to find a moment in time, except where the first bus of the list that has offset 0 is on top of the timestamp. So that timestamp will be a multiple of the bus number that is at offset 0. then this time plus 1, because 13 as of this offset 1, need also to be a multiple of 13. Then we have offset 2 and 3, but we don't care about the buses with offset 2 and 3 because the problem stated that we don't care about that. Then we have to care about the buses 59 that has offset 0, 1, 2, 3, 4. At that point, the timestamp that we have to find plus 4 must be a multiple of 59. We don't care about the x that has offset 5. Then the timestamp plus 6, that is the offset of 31, must be a multiple of 31. And again, this timestamp plus the last number that is the last offset that is 7 must be a multiple of 19. So adding x's in our list of buses obviously move the offset of these buses, of this bus in the timeline. And basically we have to find this magic timestamp that is satisfying all the criteria. The criteria is that the timestamp plus the offset must be a multiple of bus ID.
Okay. So if we were to express, now here I added all the offsets just as a reference, but if we were to express this in a more mathematical way, it's like a system of equations, and we need to find the common solution that satisfies all of them. So if we call t, let's say that the value that we want to find, our x, basically, let's call it t because it's time, so we don't confuse it with the x here. Basically, I think this one will look something like this. So the first one will be t plus 0 because 0 is the offset, and we want to find at the very first spot that autobus that
put that in brackets.
That in brackets, all of that will be modulo of that specific bus ID, so 7, that needs to be equal to 0, right?
Yeah.
And we need to do the same for every single bus. So for instance, t plus 1 modulo of 13, that needs to be 0, and we keep going for everyone. And when there is an x, you can ignore it. So here you can do plus 4, because the x are just like padding, basically. And this will be 59 equal 0, t plus 6, because again, we can ignore the next x. This will be 31 equal 0. And the last one will be t plus 7 mod 19 equal 0, right?
Okay, so this makes sense.
We have to find a t that is solving this system of equations with modulo. That is a little bit tricky because of the nature of the modulo itself. That is, tricky.
But yeah, if you had a degree in maths, you could probably solve this straight away by just looking at the equations and doing some stuff.
Yeah, but we are only poor guys that can write code, but they can't do math. So.
So now I'm gonna hand it over to Roberto, because Roberto spent a little bit of time thinking an interesting solution for this, which is much more optimized than our brute force one, where we were literally iterating from 0 to all the numbers in the future until we satisfied all these conditions. So of course that wasn't very efficient.
We started with a slightly better version than this one. I will explain it when you share my screen. This is part 2 that we did last time. So basically, the concept behind this was we have to find a number that is satisfying all the buses. We take the biggest bus ID, that is 613 in our input example. In our input, not example, in our input. And we say, we can compute the first number that is satisfying 613, because it is 613 minus the offset. That is the first number that is satisfying at least that bus. Then the next number that is satisfying that bus is that number plus again 613. Then 613 again plus. So we can take the first number and start to jump by 613 until we find a number that is satisfying all the other buses. So here we started in this line taking the max. We started with a multiplier of that max starting from 1 and going on forever. Very interesting syntax here. Always suggested, I suppose, from the chat. And then we compute this candidate that we know is satisfying this bus, the bus with the highest ID, and then we just check it against all the others. If we found a number that is satisfying all the buses, that is the solution. And it is working for this small set of inputs. So with this small set of inputs, the algorithm is working. With the big one, obviously, no, because it's taking forever to compute.
Yeah, I think we ran it for like 5 minutes and my machine was burning, and then we said, okay, let's stop it.
We raised the white flag and we said, sorry, let's time.
We'll need to buy Luciano machine.
Yeah, many machines for this problem, I guess.
Send €5 to Luciano. So, coming from that, I tried, sorry if I wrote it in Python, but I tried to find a better solution. The first step that we did, so taking a number and finding it's a number that we can jump on and looking for it to satisfy other buses, was the right idea. The only problem is that even if we were finding a bus that was satisfied by the new number that we had, we were not using that information. We were not using the test that we did. So, for example, we was starting with 59 minus is offset, and then going on. At that one point, if we were satisfying 7, we were saying, okay, 7 is satisfied, but somebody else is not, so this is not the solution. That is true. That is not the solution. But we can use that information to shrink, to increment our step, so we can jump off more, because now we know that the number we are on satisfy, for example, 59 and 7. So we have to jump by 59 by 7, because same reasoning from before. We have a number that is satisfying a bus, so we can jump off the bus ID. If we have a number that is satisfying 2 buses, we can jump off the LCM of that of the 2 buses that are satisfied, and so on. I will explain it better later. Okay.
Can you give it 1 point of zoom, Robert? Most annoying question ever.
Yeah, sure.
That's better. Thank you.
Okay, so how do we improve the solution that we have now? We take the biggest bus ID. This is not mandatory, but is faster if you do it. Then we, not what, can compute the first timestamp that satisfies the bus, that is ID minus the bus. So this is satisfied. Now, let's start with a smaller example, 3, 5, 7, and 11. Let's note that all the numbers that we are here, I think they are prime. So the LCM is very easy to compute. It's just multiplying them together. So I don't have an LCM function in this to solve it. So 3, 5, 7, 11. We take the biggest one, that is 11, with offset 3. And so we know that 8 is satisfying at least one bus. 8 is satisfying the bus 11. It satisfies only 11. There is no, we are not lucky. It's not satisfying that. So the next candidate will be 8 plus 11, so 19. 19 is also satisfying 5 with offset 1 and 7 with offset 2, because 19 plus 1 is 20. That is a multiple of 5. And 19 plus 2 is 21. That is a multiple of 7. Cool. So now we have those 2 that are true. At this point, we can start moving faster, because, going to an example with 2, 3, and 5, if I find here, for example, 30 is a timestamp that is satisfying for, now this is just an example, it's not an example from those numbers. But the next number that will satisfy all the 3 of them, 2, 3, and 5, is the LCM between 2, 3, and 5, that is 30. So every 30 steps, we will find again that we are satisfying the bus that we have. Okay, now that we have candidate 19 and a step of 385, we go on until we satisfy also the only bus that is left in our example, that was 3, 5, 7, and 11. So we satisfied 11, 5, and 7. We can jump by 385, that is 7 by 5 by 11. And we got a 403. but 404, sorry, we got a 404, page not found. But 404 is not a multiple of 3 with offset 0. Then we go again, jumping by 385, and we got 789. That is a multiple of 3. So 789 is satisfying all the buses with their offset. And so we don't have any more bus to go on. Our solution is done, and we can return the number. Here is an example with this progression of buses. That is the one that we have in the README. So 713, XX for 59, X31, 19. What is happening here? We start without a candidate. We take the biggest one, that is 59. 59 with offset 4. I think it was 4, I hope. Yeah, it's offset 4. Is satisfied by 59. And now we can step 55. And now we can step by 59. Then we go to this one that is satisfying nobody except for 59. This one again, nothing. 350. At this point, 350 is satisfying also 7 and with offset 0 and 13 with offset 1. Yeah, 13 is offset 1. I did the math by hand. Obviously, Python did the math for me. Now our step becomes 59 by 7 by 13. So the step is the ID of all the satisfied buses. We jump on by this big number, so the steps become bigger, and so the time go down. At a certain point, we have 48,000 and something that is also satisfying 19 with offset whatever it is. So now our step become 102,011. So 59 by 7 by 13 by 19. Now we start to jump by this big number, so we start crunching timestamps very fastly until we also satisfy 31. Okay, cool. We found a number that is the solution for that small stuff that is satisfying all the buses that are in the list. The next time this will be satisfied again is in this number of minutes, but we don't care. This is not something that we want to know. Our solution is just this one. So basically, we have to implement this logic. We start with a number that is satisfying any bus. Starting with the biggest one is just handy because you have a bigger step at the beginning. But if you can even step by 7, what is the first one? Yeah, 7. If you step by 7, you are getting to the same answer, just taking some more step to get there because obviously the initial steps are smaller. Cool.
This is very cool, Roberto. I like it.
This is the Python code to do that. This is not important. I parse the buses. I remove the X's. Here, I want to point out this. I created a mutable structure that contains the bus ID, the offset of the bus, and if the bus is satisfied or not. So then I take the max out of this. So I take my bus and I don't care if it's satisfied or not. I compute the first candidate minus the step because steps start at 1 because we are multiplying the number together. So if steps start at 0, we multiply something for 0. It will always be 0 forever. So we have to start with 1. So when we get in, we increment. So before getting in, we decrement. But this is just a trick to just don't have an if in here. While not all buses are satisfied. So while not all buses are satisfied, then we have to find a way to write this in Rust. It will be funny. Take all the buses, but take all the buses that are not satisfied. So for all the buses that are not satisfied, and also here I want to see how to do that in Rust. Take the bus, check if the bus is satisfied. If the bus is satisfied, the step become multiplied by the bus ID, and the bus is, we mark the bus as satisfied true, so we are not going to do it anymore. And also, if all the buses become satisfied, this while will terminate. Then we print the candidate And basically, I did that to create this table because I was lazy. And then we print the candidate out of this loop that is the solution. Okay, so this is the pseudocode of what we have to do. We have already something similar until here when we find the max. Then we just have to change a little bit of stuff, having the step and the other stuff. Also, here we have a structure. No, this is the next example. This is our bus. In our bus structure, we have to add the satisfied boolean. That is a boolean, so just an additional field, and we have to make this vector mutable.
Well, we can keep...
Or we have another vector mutable to keep track of. Or we take a bus out of the to-do list and we put it in the done list, or we mark it as done, as satisfied. I don't know what is better, to be honest.
Yeah, we have this suggestion that we could be using a different list to keep track of the...
Yeah, we can have the list of the bus to satisfy and the list of the satisfied bus. And when the list of the bus to satisfy is empty, but again, this must become a mutable vector, because if we have to remove stuff from it, we have to make it mutable. Otherwise, we can't. And at that point, we can avoid to have the Boolean here. I don't know from the performance and memory point of view if having one Boolean there is better or worse than moving stuff around between vectors, because when you add stuff to a vector, probably there is a small memory allocation, or I don't know if Rust internally just move a pointer. No idea on top of that.
I suppose if we use sets and references in that set, probably it's not going to be a big deal.
So we are moving a reference between vectors. So at that point, are we not going to fight with lifetimes?
Yes, that will be the fun part.
Yeah, if we add a Boolean, we don't have to fight that.
No, I suppose we can try both, and if it gets too complicated, we can try with the Boolean. Like, I suppose the most memory efficient solution is that you keep track in a set, right? Or not? Or maybe it's the most flexible because you don't need to change.
Well, set or vector is not a big difference. We have to cycle over the list, so it's always the linear to cycle over the list or the set. I think is the same. Because we don't have duplicated IDs, we know it. It's impossible. So in the input there are no, and there are no by definition.
I think we don't even care about order. So
yeah, the order is not important. We have to satisfy all of them, and when we find something that is satisfied, we just multiply the step and we go on. And like I said, taking out the max is just a little speed up, but I tried also without doing that. Just taking the first of the list and start with the first of the list is working. It's taking 20 additional steps, but they are not a lot. Good stuff is that we have a part 2 example working, so we can refactor the code with the new algorithm, having this still green. I think that now this is green. Yeah, test passed. So we can refactor, keeping this test green. Then when we refactor it, we can uncomment this and try with the big numbers. Okay? So
it would be interesting to do a benchmark between the original and the new one.
But the original, we know that is crazy slow. On this small subset, yeah, because the current one is not running with this. It's just taking ages.
Yeah, we could do like the small one, do a benchmark, and we'll see. Well, we'll just get a percentage value, I guess. But
okay, we have it here in the. Let's focus on solving it. Then we can do a bonus track with the performances.
Also, to answer Luciano's question in the chat, I think the idea is to have a list, and at the index is going to be the ID of the bus, basically. So it's going to be an incomplete list, if that makes sense. I think. But I'm not sure if you can do that.
That's what I was thinking, but I wasn't 100% sure. Okay. Well, let's start to implement, and then we'll see the details. We can always change the approach if we don't like it.
So, Eugen, do you want to write the code? Do you want me to go on?
I would honestly let you carry on, considering you've already done most of the hard work. If you fancy it. If not, I can drive.
No problem. So,
I can drive next time as well.
Cool. So now to mimic what we did here, but without the boolean, we try with moving stuff around, okay? Okay, I tell it. So max bus is this. We let mutable u64 step that start at 1. Then we move the candidate outside of the loop, and we have to make it mutable, and it starts at this minus step. Oh my god, what is suggesting me to do?
I think U64 in line 54 needs to go after step.
Ah, okay.
It's not Java.
It's not Java, sorry. Too many languages. So now here is the condition that I was saying. I want to see how to write that. If not, why not the buses are satisfied? But if we remove the bus from this list,
by the way, this is the suggestion from before. Now it makes sense. Instead of using a vec of bus, we use a vec of bool, and then we know that they are aligned basically in index.
Oh, well, let's keep it simpler. Let's go just with, we remove the bus from the list when it is satisfied. What do you think?
Mm-hmm. Yeah, that works, because we don't care about the bus after we've satisfied the condition.
While, how do you get the length of buses? Yeah, what I wrote.
Or nusses.
Dot
len,
size,
I think.
Size len.
No, I think it's dot len.
Len, and it's a function call as far as I remember. Or leak.
Yeah, well, it was the one above len in the suggestion. Okay, while we still have buses to satisfy, what we do? We don't need this anymore. It's the bus ID minus the offset minus the step. Cool. Now we increment the candidate by the step. So we have candidate plus equal the step. Now, for all the buses in the buses, for the bus, okay, you understood?
Do we not need, first off, it's candidate with an E at the end. There's a typo. And I think we need a semicolon there as well.
Yeah.
Sorry.
By the way, we have an interesting suggestion here. More of a comment than a suggestion.
Okay.
But I want to see the error message.
I would like to see it fail as well, please. Or not fail. Might be a good surprise.
I think it makes sense, though, the suggestion, but...
Okay, make it fail. Here I have to say that is greater than 0? No. What is complaining about? Length comparison to 0. Yeah, so? It's empty. Okay.
Also was a Clippy suggestion. It wasn't an error.
Okay. Clippy, the Microsoft one right now. So now we multiply we satisfy the bus. We multiply by the bus ID. And what was and we we put the bus satisfied. So here we want to remove the bus from the list. How do you remove something from a list by index?
Yeah,
okay, by index.
Yeah.
So we have to enumerate. Dot enumerate, and we have index, comma. I have to put them in round brackets.
Let's see. Yeah. And
a semicolon. Here is complaining that cannot borrow buses as mutable because it is also borrowable as immutable. Okay, so when you are cycling over it, you are borrowing it as immutable, so obviously it's not mutable when you are inside. And here is the problem that
that Tommaso was suggesting earlier.
Okay, sorry, I forgot the name. That Tommaso, Okay, it's true. We can't. Whoops. So we have.
But we can keep a list. We can keep a small local vector of bosses to remove, and we can remove them after the.
Okay, sorry.
After we enumerate.
Let's try that. Let's mutable the vector of bus that are
to remove whatever.
Satisfy buses. Snake case or camel case in Rust?
Snake case, I think.
Snake case. Vec.
I am thinking another approach, though. I don't know if it makes a lot of sense. But basically what we could do is change the while condition to look at an array or a list or a set or whatever where we put the satisfied ones, and we keep looping until that list has the same length
of the original list.
But then we have the same problem, because then we'll still be mutating the set.
No, we'll be mutating something else. Because here we're looping over all the bosses.
The problem is also that in this loop, you don't have to loop on the already satisfied bus.
Yeah.
Because if you loop on the already satisfied bus, you are multiplying again for the same bus ID, and so the step get fucked up.
Or we can have a quick if statement that just says, if this is a satisfied one, just continue.
Yeah, we can do
it's
that.
Not the prettiest, but maybe works.
It's easiest to just keep a vector.
Okay, there is 100 way of optimizing this. Let's try.
Yeah, let's make it work first.
Yeah, Weir is complaining about it's not add, is push. And here is the index, because we have to keep the index of the bus to remove. Big question. Now we want to do a loop on top of all the index that we have to remove, right?
Yep.
Okay, also can I remove this and make yes, make Rust guess. Rust is guessing. If I have a list with and I have to remove 2 indexes, 1 and 3, for example, and I remove 1, cool. Then I have to remove 3 or 2, because the list becomes shorter and the stuff moved. Or I have to remove from the biggest to the smallest. Because here we are going the other way around, from the smallest to the biggest. Well, we can go on top of the satisfied buses list reverse. Cool, you're right. For index in satisfied buses, but I want it in inverse order. So what I do? Reverse. Reverse.
I think it's just rev.
That's reserve you've got there. Reverse. It has reverse as well.
Reverse the order of element in the slice.
I think that mutates, though.
This is mutating it. But
I think you can do .iter.rev.
Because okay.
But do we care about? Oh yeah,
no, but
yeah,
we don't care about modifying it, but we care about efficiency a little bit. So instead of reversing in place and then using it, just reverse it on the fly.
Now, this creates an iterator that goes backwards, basically, rather than moving things around.
And here we are removing by index. And now he's complaining because we found a reference to unisize, not unisize, like this.
There was another suggestion there for avoiding the reverse, I think.
That was
instead of pushing, we can insert at the start. So on line 64, instead of satisfied bosses.push, yeah, we can insert at the start. It might be more efficient. I don't know.
No, memory-wise, it's more efficient to append to a list than adding on the front. At least depending on how it's implemented. If it's a linked list, it doesn't change a lot. But I don't think this is a linked list, because you can access by index in O1. So this is something in the memory. because inserting in at the beginning means that you have to shift everything and insert the value. Inserting at the end means that you just insert a lot more memory if you need it and just add the element. So it's faster, in my opinion. I don't know the internal implementation, but I think it's faster. Then going through an iterator in reverse is.
There's another thing we got in the chat, which is into
iter. You can use into iter to avoid the asterisk in line 69.
Okay, so to avoid this, but we can reverse an into iter, or you have to do into iter at the end here.
No, I think before.
Yeah, try it.
Let's see if it works.
Instead of iter, I do into iter.
Yeah.
But then I have reverse on into iter.
Yeah, so should work. It did work.
Seems so.
Good suggestion, thank you.
This suggestion was already being done some time ago. I always forget about it.
Yeah, please keep suggesting, especially when we forget. Eventually, we'll learn something.
We'll eventually remember.
If I didn't forgot something, we are doing everything. And the test is passing. Now is time to uncomment the big guy and comment back the to-do.
Let's see if we can hear your fan spinning.
Yay!
Nice. And it was very fun.
Fast. Fun and fast.
Fun and fast.
Okay, finish
0.00 seconds.
0.66 seconds. And
definitely better than 5 minutes, I'll say.
Well, this is 0.01, so basically taking nothing at all. So back to the suggestion how to improve this. There were various other ways that we can use. Just give me a moment. I want just to create a commit here.
Oh yeah, somebody's saying us that this is running on debug and not on release mode. Probably release mode is gonna be like 10 times faster or something like that.
Oh yeah, we tried last time to run in release mode the long time solution, but was still.
But because the algorithm there was still terrible, right?
And we can try it now and see how much faster.
It was not that terrible. It was the first step of this algorithm. We just forgot to do all the other steps.
Exactly.
We got, how much was this? 660 milliseconds? We could try to run it in release mode and see how much faster it is.
I have to take the syntax to run the test and add something dash release.
I think dash release.
Sorry, dear commit, apologies.
Just exercise 13 part 2 fast solution version 1. So if we want to now play around with stuff and do like, okay, we were saying, let's try to run it in release mode. That I have to take this guy, copy, open a terminal, go here. And what is that I have to add and where? Luciano, you remember it by memory?
I think at the very end you can just put dash release. I think that's it. Please correct me if I am wrong.
Test failed.
Release.
Unrecognized option release.
Okay, so not.
Oh, before the double dash. So before, I think that all features. Yeah.
Dash release. Okay. 0.79. That is slower. And okay, now it's already compiled. It was the first run that was low, but now is. Basically nothing.
Nice.
Very cool.
Nice. And thank you for the help, everybody in the chat. A lot of good ideas.
We are back to nothing. So, yeah, please terminate. Please close. Okay. Now, optimizations. What were we thinking? Using another list, checking if it's there, skipping. So I think that this is quite easy to read also. What do you think, guys?
I don't mind, honestly. I don't know if I would spend too much time changing it.
Okay, if somebody wants to change it and submit a pull request, do it. Obviously, only if the tests are green. Cool? And if they run in less than 20 days.
Yeah.
So we can give this as an homework. Submit as a PR on how you would improve this code, and we can discuss this next time. What do you think, Luciano?
Mm-hmm. Yeah, I like this idea. Yeah, if there is anything major that can be improved.
Cool. Do we want to jump on exercise 14?
I think so. By the way, I want to give another comment, because basically last Monday when we tried to solve this one and we couldn't solve it, well, we couldn't solve it fast enough, because I suppose that our solution was correct, just doing
it was
1
just
million things
slow.
that were not needed. So Roberto went off and he kind of did his own research. It literally did solve the problem on his own, while I was looking on YouTube how other people are solving this problem. And then basically I found out that there is an entire theorem that is called something like Chinese reminder.
Yeah, the Chinese
theorem,
reminder theorem, you said, yeah.
which is literally a theorem that allows you to solve that type of equations that we discussed at the beginning. So basically now we're going to call the Gambuzzi theorem, because Roberto just figured it out on its own. And essentially he did figure out the same solution as that theorem.
Yeah,
the
only stuff that cool. The only stuff that we are not doing, like I said, is the LCM, because all the buses ID are prime. So.
Oh, but maybe that's worth adding a comment there, because we will forget.
Definitely.
Yeah. Here we should have done a LCM, but the bus IDs are all prime. So you just multiply them by. Okay, 14. Do we want me to go?
Wait a second.
Wait,
just there is an interesting comment.
Okay.
So regarding the previous error-related borrow, I think we can use .retain function on vec. I have no idea what .retain does. It's the first time I'm seeing it, so I'm gonna do a research. Well, a Google
it as well.
This was when we were trying to do what? Change the list when we were iterating on it?
I think so, yeah.
So do you want me to try to do that again?
Retains only the elements specified.
Okay, I was thinking more that you can use cow, copy, clone on write as an alternative, but that will generate like clones of the list as you change it. So assuming that will work, I don't think it's a particularly interesting approach.
So the stuff that is addressing that, I already forgot the name, is this problem that we can't borrow buses as mutable because it's already borrowed as immutable, or was something else that we were...
Yeah, that was the one. We were trying to alter the list we were looping over.
Okay. So instead of doing this, what was the name of the function?
But there's another comment saying that it keeps a mutable reference to self, so it might not compile. Do you want to try it and see what it does, maybe?
But retain here.
Yeah, but basically retain accepts a closure. Well, you need to pass like a function. It's like a filter, basically, but with the opposite meaning, if I understand correctly.
It's the opposite of filter. Okay.
That's what I got. So it's like you retain the ones which don't have the ID that you want to remove. It might not be as good from a performance perspective.
So basically, is it the not of a map, of a filter?
Pretty much,
I think so.
Can't you do a filter just inverting the condition?
I think, I suppose, depending on your semantic, it might be more readable, but I mean, at the end of the day, yes, I think technically you're correct.
Could reassign it with a filter. Oh, no, we can't because we're looping over it. Never mind.
Okay, but well, in any case, this is
cool. Well, that's right.
Yeah, let's leave it as it is, but it was interesting to learn about retain for sure. And again, if you want to send a PR, you can.
Okay, let me also push the comment. Git add, git comment, git push. I'm lazy. Okay, so do we want to go on with 14?
Yes.
Do we still have time? Yes.
Spoiler, I did have a look and I like it. At least part 1.
So, README police was already here. As the ferry approached the seaport, the captain asked for your help again. The computer system that runs this port isn't compatible with the docking program on the ferry. So the docking parameters aren't being correctly initialized in the docking program's memory. After a brief inspection, discovered that the seaport computer system used a strange bit mask system in its initialization program. That one, you don't have the you don't have the correct decoder chip handy. You can emulate it in software. The initialization program, your puzzle input, can either update the bit mask or write a value to the memory. Value and memory address are both 36-bit unsigned integers. For example, ignoring bit mask for a moment, a line like mem of 8 equal 11 would write value 11 to the memory address 8. Bit mask is always given as a string of 36 bits written with the most significant bit 2 at 35 on the left, and the least bit 2 a power of 0, that is the 1 bit on the right. The current bit mask is applied to the value immediately before they were written to memory. A 0 or a 1 overwrites the corresponding bit in the value, while an X leaves the bit in the value unchanged. For example, considering the small program mask, that one, so we have a 1 here and a 0 here, and this program, memory of 8 equal 11, memory of 7 equal 101, memory of 8 equal again 0. This program starts by specifying the bit mask. The mask it specify will override the 2 bits in every written value. The 2 bit is overwritten to 0, and the 64th bit is overwritten with 1. The program then attempts to write value 11 to the memory address 8 by expanding everything out to individual bits. The mask is applied as follows, like this, and the 11 becomes a 73. Because of the mask, the value 73 is written in the memory address 8. Instead, the program tries to write 101 to the address memory 7, but 101 gets unchanged by the mask. This time the mask has no effect, and as the bit overwrote, where already the value the mask tried to set. Finally, the program tries to write a 0 to 8, but the 0 becomes 64. To initialize the ferry program, you need to sum all the values left in the memory after the initialization program, all the 36-bit. In this example, it become 165. Your puzzle answer is a lot.
I think we will have just a much bigger memory, right, in our input.
Our input, if we open it, is
there's different masks.
The commands. The mask changes. The memory, obviously, the memory commands are there. So every now and then we find a mask, and we have to update our mask in memory. That will mask this value. Then the mask change, and it will mask these values, and so on until the end of the program. Then we have to sum all the values that are in memory. So first step is parsing.
Parsing, it's interesting.
Yeah.
Because here we have not like a uniform sequence, but we'll need to figure out what's the type of every line, right?
Yeah, the line can be a mask or a memory. Those are 2 different commands, like to say.
Maybe we can call them commands. Yeah, that's a cool name.
That is a little bit like the ship exercise.
Right, yes.
And then we can take, if the command is a mask, we only care about one value. If the command is a memory command, we care about 2 values that are index of the memory and content that must be written in there, masked by the last mask available. Okay?
Yep.
Okay, so parsing will be long to write, tricky. From the point of view of the math involved here, if you want to discuss this a little bit, basically this mask can be divided in 2 different masks. A mask that is doing an OR on top of the value, setting the bits to 1, and the mask with an end mask. That is the mask that is needed to change the bits to 0. Because if you OR with a bit to 1, that will become 1, whatever was the input. If you end with a bit to 0, that bit will become 0, whatever was the initial bit. And this is how the mask needs to work. So we have, when we reach a mask command, we have to compute 2 different masks, an end mask and an OR mask. Then when we reach a mem command, we have to run the mem command, but masking the value, doing an end with the end mask and an OR with the OR mask. And I think this is everything. So let's start with all the parsing of this stuff.
Quick question.
Yeah.
Did you consider how are we gonna manage the memory? Meaning, like, how do we simulate this virtual memory?
I think the fastest way is a map.
Hash map.
Yes.
Yeah, I was thinking the same, because it's very sparse. Like, we don't have.
Yeah, it's sparse. I don't think makes any sense to take the highest of those values, also because we can't know it in advance. And creating a vector that big, this is a sparse matrix, and the sparse matrix, sparse array, can be done with an hash map.
Question?
Absolutely.
Do we care about the indexes in any way?
No. In this, in part 1, in part 2, yes. In part 1, no.
So then for part 1, we can just use a vector of the transformed values, and that's it?
To be honest, we could even use a vector of this string. Vector
no, but we don't care about that part, right? We just care about the value as it's transformed by our masks, and that's it for the end, because we just need to add them.
Yeah, but they can be overwritten.
Okay, fair enough.
I think that, like in the example that we have here, the 8 is overwritten.
Yeah, you're correct. Sorry, I somehow managed to forget from 30 seconds ago. So yeah.
I don't know if this number, no, this is only, there will be some index that is replicated, that is there twice.
Okay, hash map then.
For sure. Well, obviously I'm not finding them. Yeah, this one is here 2 times, here and here. So we have to set it the first time with this mask that, and then we have to set the second time with this mask that. To be honest, it would be enough to set this with this mask that is overwriting it. But the problem is that scanning the input linearly, we can't know if this is the value.
You will need to remove duplicates and stuff.
Yeah, but removing the duplicates, you do that with an hash map. So let's go with an hash map.
Yes, exactly. You will override.
Yeah, let's go with that. So we need an hash map as key. Like I said, in theory we could even use all this string, because why not?
There's no reason not to.
It would be a little bit easier to parse.
If we want to parse the number, or if we just want to take the string, it's really up to us.
Spoiler: in part 2, you have to parse the number, but for part 1,
let's parse the number.
Okay, let's parse the number.
I mean, if we know we're going to need it, might as well get it done, right?
Yeah, so it's not a big deal. We know how to do that.
We can do a common parser and use it for both the parts. Okay, cool. So here we have to start with defining commands, like enumeration of commands.
I think that will be similar to what we did with the ship exercise, where basically you have an enum of commands, and then then eventually we did something different.
Yeah, because it also has a value. So there was an exercise with that.
Yeah, I can suggest, if you want, where basically in every variation of the enum, we can include arguments that are different. For instance, if you take the input for a second.
Okay, the input.
For instance, what I'm thinking is that the first command, like the mask type command, has only one argument, which is some visualization of that mask. Could be a string. We can discuss that later.
But we pass a string because we need also to consider the axis.
Yes. And then the other variation, which is an assignment, you need two values.
Two
So
parameters.
you can create
Address.
a variation that has the address and the value you are trying to assign.
Okay.
So I think we can do all of that with just one enum and the variant having different values.
So being a lazy guy.
Yeah, for instance, here you see you can put, it's like a tuple, right? Every variation can have values, but they don't have to be uniform. Like you could have a value.
Okay, they can be different. Oh,
yeah,
cool,
exactly.
Cool. So our instructions are a mask and a mem.
Are you changing? Oh, you just copy pasted. Okay.
Yeah, I think I copy pasted.
I think it's better if you just do a string for now, like a type string, because otherwise we'll need to deal with lifetimes. So for now, let's just do a string and maybe we'll have fun later trying to use str.
So I think that we have... no, there are 36-bit. So we have to use as value at least I use 64 because we have 36-bit. For the addresses, I think the same because why not? Everything say that is 36-bit, so we go with a U64 that is enough to contain 36 bits.
Mm-hmm.
And so we define our instruction that can be a mask with a string or a mem with this guy. Then we define a function, or we implement the parse on top of. So basically, we want
to implement.
We want our instructions to be a vector of inst, right? This is not the syntax.
You need the angle brackets.
But you need the angular brackets.
Yeah, sorry, this is not the syntax.
And you need to assign it with whatever. Yeah, empty.
Just to start. Well, it's empty. We have to do our
make it
parse.
mutable.
Okay. But we can't do something like...
You could do a function if you want.
Yeah, we can still get the lines, right? Or, yeah, we could do that.
Yeah, we are doing this guy. That is input lines.
Lines, yeah.
Yeah. Okay.
Yeah, now the tricky bit is going to be we need somehow to analyze the shape of the line to figure out is it a mem or is it mask assignment.
So we can't collect with a type and then implement in the instruction enum the parser?
Oh yeah, we could do that, I think. Actually, I like that. Yeah, let's do it.
So we can collect directly on lines, can we?
Yeah, we
you can collect.
Okay, input is with underline because otherwise it was...
Better if you remove the underline in both places. I don't think you can collect because basically what we have is going to be a sequence of str, and we didn't implement any way to convert an str into an inst, which is something that we can implement now.
Okay, we can implement it now. But
so I think we can implement this with the from trait.
We also received the from str, exactly, from str.
Or the from str, which is even better because that's the one that we did implement last time and was allowing us to use .parse. So thank you, Tommaso, for remembering us that we don't remember our solution. So eventually we'll learn. Keep pushing us.
Okay, how do we parse this? From str.
I think in the old example, we were just looking at the first character and then the rest, because we were getting stuff like north and then a value. In this case, I think we need to look at the first 3 characters. That's probably the simplest way to figure it out. Or split on equal.
Good idea. because we always have either mass or mem as the first three characters.
Yes.
So we can just do a straight compare of, I think we can do like a string slice and just compare them, like if they are the same.
Then we can split on this later.
Do we have any fancy starts with or that kind of stuff?
There might be also
string?
starts with, I think, yeah.
Oh, yeah, cool.
The pattern
is either mem or mass.
Yeah, also mask. Why not everything?
Fair enough.
It doesn't seem happy though. Can you save? Oh, okay, it is happy. Cool.
There is else if
With space.
else if.
Yeah.
Oh, okay.
Like
JavaScript.
You can tell who is coming from JavaScript.
Exactly.
Here we can raise an exception. I don't know how to. We can return a null.
Return no error. And in parentheses,
What?
you need to put that unit type. So parentheses again, I think.
Like this?
I think so.
Do we not want to panic though for invalid input basically? Because it's supposed to be just one or the other, right?
Yeah, the input we know that is fine, but okay,
I don't know what would actually be nicer. Yeah, we can do this for now. It's the first time we do it. Every other time we panicked.
Yeah, who cares?
No, let's because we are. So this is actually a good point. No, so now we are implementing that trait called from str.
Yeah.
And this is an interesting one because this trait is taking into account that the parsing can fail.
Yes.
So if
you
you can
don't
see,
have to panic.
Yeah, exactly. In line 11, it is expecting a result. So the most idiomatic thing to do there is to just return either an error or okay with a value.
Can you return a known as a result?
I don't think so, because that is a different... It's a variant of a different enum, which is going to be the optional enum. But then we saw that there are ways to convert between each other. For instance, you can convert a result to an optional with .ok. Probably there is like the opposite as well. I'm not sure actually, but there might be, yeah.
Okay. Well, what if it is...
Okay, by the way, Tommaso was suggesting something interesting, that if we split on spaces, is that going to work for both the instructions?
There are spaces before, after the equals.
No, because we have the square brackets. Okay.
No, we have the square brackets, and we need this number to be parsed.
Okay, so we need to have very bespoke, functions for the two cases.
We can split on this if it is a mask, and we can split on this. We can take this substring and split on this if it is a mem. So we have to do two different logics there.
To be honest, for the mask ones, we can probably get a substring like we did on the last thing, because we start at character 7 and then go all the way to the end, right?
Yeah, this is true. Okay, so if it is a mask, we have to return a new instruction that is a mask. So how do I do that?
You could do that slice trick that Eugen was suggesting.
Yeah, but how do I return a mask?
Oh, yeah, it's instr column mask, and then there you specify the value.
There a string. So how do you cut out a slice of a string?
It's just called S, right? So you do S and square brackets, and then you can say the starting point.
Dot. Yes, this is not Python. But the type say that
needs to be a string. So you can take all of that and do dot to string, I think.
Or change the type.
No, I don't think that's gonna work, because it's gonna tell you that it needs to be a reference to str. Try to save.
Borrowed type always have a statically.
Yeah, because str doesn't have a known size at compile time.
Okay.
So you can do reference to str, and then we enter the realm of lifetimes. And
no,
or
thank
we can
you.
go to string
from all of that. Yes.
Yeah.
No, thank you. I want to leave.
You want to live without life cycles.
Oh, it's still not happy though. From str. Oh, you might need to pass it a reference, or.
Oh, maybe he wants an ampersand s. Try that.
Yeah.
Okay. Well, I don't care if S was destroyed after this, but probably he cares. But also he's passing a reference, so yes, he cares.
Rust can't know if we care or not. Although that would be cool.
Instead, we want to return a mem with two different values that we can extract them here. Let address value equal to underscore.
Don't you want to split on like specific thing?
Yeah, I want to split on going back to our input this string, but starting from 0, 1, 2, 3, 4. Where is the editor? So basically, I want to do at this point and as from 4 on.
Yeah, then the split.
And I want to split on this. So the first part will be the address as a string, and the second part will be the value as a string. Then we have to parse them, but you can't do this in Rust.
I think the problem is that when you use .split, it's going to give you an iterator. So we'll need to do something like, I don't know if collect will work, but the idea is that you need to start the iteration.
Let's try to collect and see what it does, but you might need to specify. Try a collect at the end and let's just see what it does. And probably in the meantime, somebody in the chat will tell us what it does. No.
Here I can say
no,
that
probably now collect is... Yeah, let's do that. And I don't know if that can work either, because it's probably giving you STRs. So probably we'll need to do like a map in between if you want U64.
Okay. Collect. You want to change the type, mapping it. Mapping it to U64 parse. There is something like that.
Yeah, you can just do.
I think from no.
I think U64 column parse might actually work.
Partial CMP. No, there is no.
No, then try to do S as a variable or X, whatever you want to call the current value. And you need to use the pipe, and then do X dot parse.
No suggestion.
Interesting. And dot parse, I was thinking that you need to specify. Do you need to specify the type?
This is JavaScript. Sorry.
Oh yeah, the arrow. You need to remove the arrow. Yeah, that was. This is JavaScript. This is Sparta. Okay, now it still doesn't know why.
No, it's complaining about the types that I wrote here. Why you don't write the types like this?
Yes, save.
No, I say that they doesn't want it get it as 4 different variables instead of.
Did you put the comma? You did.
Like this is better. Oh, the comma is here, and U64 is U64.
Oh yeah, you don't have. Wait, because you are giving it names.
Okay, let's not give them names.
No, I'm thinking.
I don't think it
I don't
knows
think
it's
that
gonna
collect
have just you.
can collect a tuple. That's what I'm worried about.
Okay, so let's go back. So let's remove all of this, and we just want to split.
Yeah, and then basically we can take the first and the second. It's probably easier and assign them. Yeah.
Now this is a split string, so it is this type. I want to take sorry if I do this in multiple lines. Let address equal to this. I want the first one. There is a first.
So first, or just call next.
But this is not an iterable either.
It should be an iterator. Can you just call dot next? Because next will give you the first one. Yeah, next.
And then I want it as this is an optional.
That will be an option because of course it might be empty.
Wrap dot parse.
But you have to give it a type first.
Yeah, IU64.
Without the space. Yeah.
Okay, so let's do the same for the value and then see why it is not happy.
This is JavaScript.
Mismatch type accepted. U64 found unenum result.
What?
Next is giving a result. Then I unwrap
Yes,
it.
because parse, remember, it can fail. So either you unwrap again, or you need to deal with the error, right?
Yeah, let's do the dirty stuff this time. Okay, at this point, I have my address and my value. This is terrible. And I can just return an okay with that, right?
Yeah.
By the way, Tommaso was suggesting unwrap and mute, but interesting enough, do you remember that with some other iterators, when we were calling .next, we needed the iterator to be mutable? For some reason, with that type of iterator, we don't need to make it mutable.
With this
Don't
type?
ask me why. Yeah.
Okay. I believe it.
Probably because it's a static string, so it's still in memory and you are just moving around, so you are not really changing anything, but I don't know.
Okay, now to see if this works at this point, this collect is still not happy. Bye.
There is another error.
Where?
Okay.
Cannot... the trait from iterator is not implemented for vec of instruction.
Oh, yes. Can you do a dot map and call x dot into? No, x dot parse, sorry. And then do we need to unwrap? We need to unwrap, I think, yes.
Probably.
Is that gonna figure out the type automatically?
Yeah, vector of instruction. Well, do you want to remove the vector of instruction?
No, that's not gonna figure it out. But I was surprised that with that it did figure out that in the middle we are producing an instruction.
Let's try print line. Here we need. I don't remember. No,
with curly.
Yeah, sorry. With curly brackets.
And then we also need to implement the bug. Well, derive the bug for...
derive the bug, okay. Derive the bug like this.
Exactly.
Just to not be lazy and not copy and paste code around, right?
Exactly.
I have to implement it on top of the enum, right? Implementation.
Cool.
So let's do this. Part 1. Let's try to run it. Boom.
Oh, there's another suggestion from Tommaso where we can replace the little lambda that we did with
instrument parse.
Parse. Yeah, maybe.
Okay.
Colin.
Let's see
let's see why it failed.
So cannot borrow, add value as mutable.
This is behind an ampersand reference.
Yeah, this is the stuff that you were telling before, Luciano.
Okay, my understanding of Rust, you can see, is not
cannot
accurate.
Borrow as mutable as it is behind a reference. Is a reference, so the data it refers to cannot be borrowed as mutable.
My temptation will be we just do a string copy of that str and we work on that, but it's super hard.
The bar is low, but let's...
I want to take a string, split it into parts, and work on the 2 parts. It can't be that hard.
And it should be feasible without mutating, right? Because
I'm just...
So the suggestion here is this one.
But doesn't the declaration of mute have to do with what that whole... okay.
Okay, variable doesn't need to be mutable. Are you sure?
Let's run the test and find out if it did.
But you just told me that you want it mutable. No, it's...
Yeah, it didn't help.
Is it the same error?
Yeah. To me, it's the same error. Yeah. Consider changing this to be a mutable reference.
I see. Okay.
Okay. Now you explain it to me. If he's okay.
Yeah, I don't know if I can explain.
I don't think I...
So that reference, you can also, when you put the ampersand, it's like you are borrowing. So here is like, I want to borrow that, but in a mutable way. This is my reading of this. Please, chat, correct me if my understanding is wrong.
So remove return. Okay, so I do like this.
Oh yeah, if you don't put the perfect, yes. And still you don't need that mute in line 16 on the left-hand side because the reference is mutable. That variable is not going to change. It's the value pointed by the reference that is mutable.
Okay. I completely don't understand this. Cool. I feel very stupid in this moment. Okay, so we were able to parse the input in just half an hour. Cool. So we have a string, we have numbers, and now we have to play the Basically, we have the program here, parsed. Now we have to play the program.
Write an interpreter for this program.
Now we have to write the interpreter, exactly. We want to do this next time because it's already 1 hour and a half that we are here, guys.
I think that's a good idea. I think we did good progress.
Before people try to suicide looking at us, it's better to...
Exactly,
yeah. Remember to send a PR for the exercise 13 part 2 if you want to change something in how we implemented the code. Feel free to submit a PR. Don't submit a PR for this. We're still doing this. Just for the previous one, not for the 14th. Cool.
Sounds good. So
next time we will implement the interpreter for this code.
And probably do part 2 as well, I suppose.
Yeah, part 2 is tricky. We will find it out.
Okay, we'll see. I've not seen them unlike you, so yeah.
But definitely we'll be able to start. I am hopeful that part 1 is not that crazy complicated.
No, I think the parsing was harder than the solution. And I have to study what is this guy doing here because I got a little bit lost on this line 16.
Yeah, the way I read it is that when you use the ampersand, you are saying I want to borrow this value. And the variation of that is like when you want to borrow it in a mutable way, you have to say borrow with mute, like ampersand mute.
Yeah, but what I'm asking myself is I'm taking S from 4 going on, so I'm not muting it. I'm not mutating it. I'm just taking
I think it's the dot split.
It's the dot split.
It gives you something that you are going to mutate. It gives you like an iterator type.
And if we do this, there was something that we were not allowed to do this for some reason.
You can never do just S because I think you need to know the sides.
Okay, so let's keep it like this.
Also, Tommaso was suggesting if we could try to use instruction parse.
True. Let's do this before wrapping around here. Instead of doing this guy, inst parse that I
think without the parentheses.
Yeah, but we did implement the parse. We implemented the from string. Do we have to implement something?
From string will automatically give you parse.
No variant for associated item named parse found for enumerate instance.
Is it again because parse will give you a result and not directly an instruction? Like, what if you put result of instruction there? So if you wrap, on the left side,
in the type declaration,
you do like a vec of result and then square curly whatever angular brackets.
Result or results?
Result. Save.
Oh,
sorry, it's result, right?
Yeah, I think I remember.
No, result needs to have the second type, so you need to do inst, comma, and parentheses, empty parentheses. Yeah, the unit type. Okay, that still doesn't work.
No.
Okay, so probably we will not use a generic method there.
See, parse documentation, for example. Okay, so this trait is the trait for parse, and we are implementing it, it seems. That is returning a result of self and self in error. Cool, thank you. So why we can't call instruction parse?
Okay, let's try with this one, from str rather than parse.
Okay, calling explicitly from st. No, it's not called. No, sorry. The function is called like this. Sorry.
No. That works.
Yeah, okay, but now we have a bunch of result, not a bunch of.
Yes, exactly. But the other suggestion is this one. This is a good exercise to understand the type system.
Yeah. So
because we are parsing the string, we are not parsing an instruction.
So this is again that blanket implementation that I think we have found a couple of times, where basically in Rust you can create generic implementations where you say, if there is any type that implements from string, for instance, I'm going to implement parse for that type automatically. So there is a little bit of magic that sometimes you implement a trait and you get a bunch of additional methods that you didn't have to write.
But lines is not giving us a string, it's giving us an str. We can do the same for str.
Let's try.
Yeah, we can.
Nice.
But
now the only thing is that we have that
as a result. If we want to unwrap into instructions, what can we do?
I don't know if you have like a iterator version of unwrap. I have no idea. That would be interesting.
Yeah, just to unwrap everything inside and make them no more
without having to do a map, because of course
do map. Okay, if I do a map, thank you. But let's try to write it and see if
no, before collect you have to do that. I think that map before collect.
Yeah, the first one's giving you the result, and then before you collect them, you want to transfer.
Yeah, collect to just trigger the iteration.
So we do another map. That my God, where am I?
You have another suggestion of filter map.
Oh, yeah.
And then here we were saying on top of X we do X dot unwrap. At this point, if we run it, okay, we are back to the previous scenario where we have value and not result.
The suggestion of filter map could be interesting, I think, if we wanted to ignore lines that are not successfully parsed. Here we want to parse all of them, I think.
No, but probably filter map is resolving the result for us.
Let's see. It could.
Okay.
No.
Probably not.
Doesn't satisfy iterator.
So
by the way, Illetid, thank you for the follow. And we have a question. Where are you from? Who wants to go first?
But from in this life, originally I'm from Italy, but I live in Dublin from 6 years ago, 5 years ago, and half.
Go, Eugen.
All right. I'm from Romania originally, and same as Roberto. I've been in Dublin for the last 6 years or so.
And I am like Roberto, originally from Italy, been in Dublin for, I think, 6 years. And somebody's telling us that with the avatar of Mario, by the way, which is the most amazing avatar ever, that our accent is "It's a me, Mario."
Oh, mamma mia. Okay. That was terrible. Don't do that again.
Yeah, our accent si sente, which in Italian means you can feel it. Yeah, that's very Italian.
You can feel the pain.
You cannot hide it, right?
Yeah, you can feel the pain of the English language while we slaughter it.
It's not that bad, man.
Okay, guys, we can go on next time. At this point, yes, we can parse, unwrap, filter map probably is also resolving the result. I was not able to make it work, but we can do this next time. Cool.
Yeah. So just to wrap it up, because I think we have to go to dinner, right? I have.
Why not?
So the usual foreclosure stuff is you can find the recording on YouTube, and the link is on Twitch. If you check the About section, you'll find the link. If you're watching this on YouTube, we do live streaming on Twitch every Monday, 5 p.m. GMT. So make sure to check the Twitch link in the YouTube description and give us a follow so you can be notified. And that's all. Feel free to leave us comments or send us PRs. Again, the repository, you can find the links basically everywhere. But if you're watching this is where we put all our code. Feel free to have a look and send us comments, PR. Everything is very well accepted. We are trying to learn Rust, so don't expect our solutions are the cleanest. If you know better ways to do things, let us know so we can learn. Any additional words, guys?
Thank you for all the good suggestions and collaboration today. It was cool. Like a lot of comments came in with interesting ideas.
Yeah. And that stuff here, I truly have to read about it.
Yeah, ampersand mute is definitely the homework for the day.
I have it here, and
okay, guys, thank you very much. Bye. See you next time.
See you next time.
Bye.